we're going to take a look at today requires you to do one thing and one thing only. Think. Okay? Now, what we're going to do is we're going to take a look at what's called inductive reasoning. Part of what we end up doing in geometry is we are always building a logical argument as for the reason why something is the way it is. So inductive reasoning says the process of reasoning that a rule or a statement is true. Just because several specific cases are true, inductive reasoning can be used to formulate a conjecture about something. Now, a conjecture is just simply a statement that is believed to be true. So, if I were to look at example 1 here, do you believe that you could figure out what the next pattern would look like? Of course, you actually have to look at the screen and pay attention and follow along. So it's the listening exercise. So by looking at this, do you know exactly what is going to be for the next set of blocks? Not that difficult, is it? So how would you describe how they did this? Add 2. Okay, add another column, right? With one extra block. Add a column that goes up one more higher. Could I say that, well, gee, I want to put another row on the bottom that has one more block? Would that do it too? Yeah. So a conjecture is something, okay, this is true because of this, okay? So we got a conjecture, we kind of got an idea on how we can go and put these together. Let's see. Let's try this one. Testing a conjecture. It says Michelle made a conjecture. The expression 6n plus 1 and 6n minus 1 will always result in 2 prime numbers. Do you know what primes are? No, there's an even number that's prime. Prime numbers are simply divisible by 1 and the number itself. So, 6n plus 1 and 6n minus 1 always come up with a prime number. So, and it says for n is equal 1, 2, 3, so on and so forth. So let's plug this in here once and see what we can come up with. Now, a lot of times you'll see something and we kind of think of it as more like jumping to conclusions. Okay? We see all these things happening. See, like, I suppose I could say I'm jumping to conclusions if I look out in the class and I just see a student sitting here like this. Could I jump to conclusions and conclude that, well, gee, I see a student sitting like this. They're always sitting like this. Are they paying attention to me? Probably not. They could be, though. So that's jumping to conclusions. Based on what I see, I made an observation. I said, well, it must always be true. It's kind of what's happening up over here. So I've got 6n plus 1. I have 6n minus 1. Well, what happens if I plug in the number 1? Well, here that goes 6 times 1 plus 1, which is 7. Here, 6 times 1 minus 1 is 5. Are they prime numbers? Okay, so far so good. Let's try it with 2. So that means that I have 6 times 2 plus 1. Well, that's 12 plus 1, which is 13. And here it's going to be 6 times 2 minus 1, which is 12 minus 1, which is 11. Are those prime numbers? Yep. So far so good. So let's see if I try 3. What do I get? If I go and do that, I get 6 times 3 plus 1. 6 times 3 is 18, plus 1 is 19. 6 times 3 minus 1 is 17, right? It's got to be true. It has to be true. I suppose I'll do one more just to check. So I got 4. 6 times 4 plus 1. Well, 6 times 4 is 24 plus 1 is 25. Is 25 prime? No, because 25 is also divisible by 5. So her conjecture, her thought, her idea that this was going to be true is wrong. I found 1, 2, 3 instances where it worked just fine. But all I have to do is find one that doesn't work. And the whole conjecture is blown. Nothing. Can't use it. Okay? So now, okay? So it says, Mariah looks at the diagram below and conjectures that the number of triangles in the figure is given by the expression 2n plus 1. Is this true? Well, let's try this. If I were to think about it, kind of on the different side here, and say that, you know what, I see that's growing, that's growing, that's growing, and that's growing, and this one's doing the exact same things, right? I've got 2 columns, right, that are growing. And let's see. I could say this one has, that's the first row, that's the second row, that's the third row, that's the fourth row, right? So that could be the 2 times n, right? Is there always one stuck on the bottom? Plus 1, because that one is always right there, right there, right there, right there. And it's always going to be there. So does it appear that she is correct? Yeah. Because it looks like all they're doing is just adding on another triangle on the top, right? And building it up that way. So she's correct. There is more than one way of going through and verifying it. I mean, I could plug in the numbers for 5 and then draw one out for 5 and see if it actually matched. I could do that too. So, let's try this one. A researcher studying crows for several years made the observation that every crow she studied was black. Her research assistant made the conjecture all crows are black. How can this conjecture be tested? How can it be proven? Why before you shake your head? Are all crows black? Are you sure? Okay, so is it possible that albinoism could be a condition for crows? Well, we've seen, there's albino squirrels, and I mean, it is a possibility, correct? So we could have it happen, but if very rarely, but do we know it happens? I guess I'd have to see a white crow in order for me to go and make sure that I can make the statement then that, yep, there is such a thing as a white crow. If I saw a white crow one time, then I can go and make the statement that all crows are black is incorrect. Well, yeah, I mean, if I wanted to go and post it on the internet and say, oh yeah, that's on there, but that doesn't. What's on the internet? That isn't always true, is it? People always do strange things. But the statement that all crows are black can't really be tested. Is it possible to go through and find every single crow in the world? It's possible to find every single crow in the world? It could be, but You honestly believe that you could find every single crow in the world? Possibly, possibly, but I doubt it. It's like counting all the grains of sand. It's not going to happen. So, no. So, since it's impossible to go through, we can't prove that this is the case. If we found a white crow, we could disprove it, but we can't prove that this is true. So, when we are talking about these things, we need to make sure that we can identify a yes or a no. So, what I want you to do, and I'm going to give you a minute or so here, and I want you to go through and see if you can come up with the answer for this one. That's how much time I'm giving you to work on this. So I mean, you've only got a minute and 14 seconds left. You got to be working on this. Paper, pencil, do. All these things are done. Let's talk work. So, oh, what do you believe is the next number? 89. Why do you say 89? Excellent. So that's recognizing that there's a pattern there. 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 was 5, 3 plus 5 was 8, 5 and 8 is 13, 13 and 13, or 8 and 13 is 21, 13 and 21 is 34, 34 and 21 is 55, so 89 would be correct. So by going through and identifying what the pattern was, you were able to determine what the next number would be. Excellent. Good. So, well, do we have a rule now for working with this? 89 plus 55, because I know what the next number is, I can go and figure out what the next number of the sequence is. Okay? So I'm going to give you about a minute and a half, and I want you to think about this one. Write it out, work it out, see what you can come up with. Please be quiet and do what I ask. So, hey, do you believe that this is true? Okay. So, say yes. So it wants every even integer 4 through 14. So I've got 4, 6, 8, 10, 12, and 14, correct? So, how can I write 4 as a sum of two prime numbers? Do you all agree? Okay. Do you know what the prime numbers are? All prime numbers have two factors. Only two factors. One and the number itself. How many factors does one have? One. One is not a prime number. But could I write it this way? Okay, is 2 a prime number? Okay, so we've got that so far. So we know that this one didn't work. Okay, so can we write 6 as the sum of two prime numbers? 3 plus 3. Okay. Can I write 8 as the sum of two prime numbers? 4 isn't a prime number. 5 plus 3. Okay. Can I write 10 as the sum? 7 plus 3. Can I write 12? 9 but 9 isn't a prime number. 5 plus 7. But you got a prime numbers. You got to remember the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19. Keep on going. So, is it possible to write 14 as the sum of two prime numbers? 7 plus 7. You've got 3 plus 11. So you got a couple different ones there, right? Could have. Is there any others that I could use? Probably not. That's it. So we have to make sure that when we are looking at these things, we know what we're starting with, what we have to work with. So knowing what the prime numbers here is an important thing in order to answer this conjecture, correct? So, all right. I want you to think about this one. I'll give you some time to think on that. Oh, this is more math than everything else. It's logic. Logic is a requirement of mathematics. Everything is built, see, math is all built upon rules. Well, of course they are. So if tomato is a fruit, and tomatoes are defined as fruits, right? Could be. Now, yes, sir. Grapes grow on vines. Are there other fruits? Watermelon is a fruit. And it grows on a vine. bananas grow on trees. Blueberries, you got strawberries, you got all kinds of berries that grow on bushes. So, all you would really need to do in this case is identify one thing that doesn't fit with this conjecture. Then you have disproved it. Okay? So, that's all I got for today, and you can get to work on the homework.